Hello Marians, welcome to another session, and today's discussion is about solutions. To begin with, let us discuss the types and properties of solutions. What is a solution? A solution in a system in which one or more substances are homogeneously mixed or dissolved in another substance. It has two components, solute, one being dissolved, and solvent, one that dissolves the solute. Solutions are known to be homogeneous in nature, which is why, though classified as mixture, only one phase is distinguished. The general properties of solutions include the fact that solution is a homogeneous mixture of two or more components, solute and solvent. Solution has a variable composition. The ratio of solute to solvent vary. Dissolved solute is molecular or ionic in size. Solutions can either colored or colorless, but it is usually transparent. It is a system where solute remains uniformly distributed throughout the solution and will not settle out with time, unlike suspension. Lastly, solute generally can be separated from the solvent by purely physical means. Example, evaporation. In understanding solutions, another important thing to know is its type and types of solutions can be categorized according to physical states, concentration, degree of saturation, electrical conductivity, and polarity. The first category is according to physical state, in which gives 9 different types of solutions. It is also important to note that many solids are solid solutions, and that most liquid solutions has water as a solvent, being the universal solvent. Gaseous solutions, of course, are easily formed. It is important to remember that types on this category vary on the phase of the solvent and the solute. These are the 9 types of solutions according to phase, and some of the examples. As seen in the matrix, the types are dependent on the solute and the solvent phases. So we have example here for the gas-gas phases, which is air, water vapor. For the solid gas phases, we have gas stove lighter. For the liquid gas phases, so we have chloroform in nitrogen gas. For the liquid type, so we have gas-liquid phases, so we have carbonated drinks. Also for solid liquid, we have salt water. For the liquid-liquid phases, so we have antifreeze, acetic acid plus water, or alcohol plus water. And for the solid type, we have gas-solid phases, so we have hydrogen gas in platinum, hydrogen gas in palladium. We have solid-solid phases, so we have example here, brass. For the liquid solid, so we have dental amalgam, mercury plus lead. Another way to categorize solutions is according to concentration. Concentration is a characteristic of a solution that expresses the amount or quantity of solute dissolved in a solvent. So there are 2 types under this category. First, the dilute, which contains a small proportion of solute relative to solvent, and concentrated, which contains a large proportion of solute relative to solvent. One best way to understand dilute versus concentrated is through this picture, having the round particles representing the solute in a solution. The dilute has less solute and more solvent as compared to concentrated with much more amount of solute than solvent. Okay? Let's proceed to the third way of classifying solutions, which is according to saturation. Remember that saturation is known as the degree or extent to which something is dissolved or absorbed compared with the maximum. For this category, there are three types, which includes saturated, a solution that contains the maximum amount of solute. Okay, it also includes unsaturated, which contains less amount of solute, and lastly, supersaturated, which contains more than the maximum amount. Okay. Another way to categorize solutions is according to electrical conductivity, which gives two types, electrolytes and non-electrolytes. Electrolytes are solutions that conduct electricity, which has two types, strong electrolytes such as sulfuric acid, which produces bright light, and weak electrolytes such as acetic acid produces dim light. Okay? On the other hand, non-electrolytes are solutions that do not conduct electricity. The last category is according to polarity. First is polar solutions, which consist of dipoles like water, sodium chloride, potassium bromide. Another is nonpolar solutions, which do not consist of dipoles, usually organic solvent like benzene, oil, hexane, etc. etc. Okay? Let's proceed by discussing a very important concept about solutions, which is known as solubility. Solubility is known as the maximum amount of solute that dissolves in a given amount of solvent at a specified temperature. Solubility is affected by factors such as nature of the solvent and the solute, temperature, and pressure. Let's discuss the first factor, which is the nature of the solute and solvent. This is actually based on the polarity, which follows the principle like dissolves like. In the sense then, polar solvents will dissolve polar solutes just like water and alcohol. Non-polar solvents will dissolve non-polar solutes just like for grease and gasoline. Okay? Another factor that affects solubility is temperature. For gases, in liquids, solubility decreases at high temperature, while for most solids in liquids, solubility increases at high temperature. It is also a fact that for some substances, solubility remains constant even if there is a change in temperature. Okay? The graph shows the relationship between solubility and temperature for some substances. As in the graph, they generally follow the same pattern, having some exemptions such as sodium sulfate, which solubility gradually decreases after a certain temperature. Cesium sulfate nanohydrate, on the other hand, has inverse relationships, while for the table salt sodium chloride, its solubility is not much affected by temperature. Okay? The last factor is pressure. It is known to have very little effect on solids, on liquids, or liquids in liquids. However, it marked great effect on solubility of gases in liquid. The solubility of gas increased with an increase in pressure, which is mathematically described Henry's law, which states that the solubility of a gas is directly proportional to the partial pressure of a gas. As pressure increases, solubility also increases and vice versa. Okay? Another important thing to remember in relation to solubility are the factors that affect the rate of solubility, which includes particle size, temperature, concentration of the solution, and agitation or stirring. Okay? Let's continue our discussion by knowing more about another important concept in solutions: concentration. Okay? Concentration is described by the amount of solute present in solution, and there are varied ways to express concentration, which includes percent by weight, percent by volume, proof, percent by mass volume, mole fraction, mole percent, molarity, and normality. Okay? The first way to express concentration is percent by mass. This describes a solution by parts of solute per 100 parts of solution. This is used for solid solutes since mass is a stable unit. This is mathematically expressed as percent by mass is equal to the mass of solute over the mass of solution times 100%. Remember that the mass of the solution is the sum of the masses of the solute and solvent. Okay? Another expression is known as percent by volume, which is the ratio of the volume of the solute to the total volume of the solution, and is used for liquid solutes. It is represented by percent by volume is equal to the volume of the solute over the volume of the solution times 100%. This is having the volume of the solution as the sum of the volumes of the solute and the solvent. Okay? Another unit is known as proof. This concentration unit is used by the beverage industry and is equal to the twice of the volume percent. Hence, mathematically, proof is equal to percent by volume multiplied to 2. Okay? Another equation is percent by mass over volume. This expresses concentration as grams of solute per 100 ml solution, which is used for solid solutes. It is represented as percent by mass over volume is equal to the mass of the solute over the volume of the solution times 100%. Volume of the solution is the sum of the volumes of the solute and the solvent. Okay? Another important expression is known as the mole fraction. It is the amount of component of the solution expressed in moles per mole of the solution. The sum of the mole fraction of the component is always equal to 1, and this unit is measurement is actually unitless. Through equation, mole fraction of any component, either solute or the solvent, is equal to the number of moles of the component divided by the number of the moles of the solution. So the number of the mole of the solution is equal to the sum of the number of the moles of the solute and the solvent. Okay? Mole percent as another unit is highly dependent on the mole fraction. It is the percentage of the total moles that is of a particular component, and it can be obtained from the mole fraction. It is given by the equation mole percent is equal to the mole fraction multiplied to 100%. Okay? The next expression is the most common unit of concentration. It represents the moles of solute per liter solution. Units are molar or mole per liter. It is given by the equation molarity is equal to mole of the solute divided by the liters of solution. Okay? Another unit is known as molality, which is used with varying temperatures since volume is dependent with temperature. It describes a solution through moles of the solute per kilogram of the solvent. Its units are molal or mole per kilogram. It is represented by the equation molality is equal to the mole of solute divided by the kilogram of solvent. Last unit to be discussed is known as normality. It is based on an alternate chemical unit of mass called equivalent mass. It is described by the number of equivalent masses of solute per liter of solution. And the units are N or equivalent per L. It is given by the equation normality is equal to the equivalent of the solute divided by the liters of solution. There you have it, class. That's it for today's session. Thank you and stay safe.